Um, Hello to any remote people who might be joining. I don't know how many of you there are, but also welcome. Yeah, it's funny that you brought up server-side rendering because that's totally not in my talk, but I should probably still talk about it because it's something we actually put a lot of effort into making it easy. So maybe in any of the future sessions, we can also get into that. So the thing I wanted to focus on in this talk that I prepared for is API developer tools. So basically, a lot of times when people talk about GraphQL, they talk about stuff like mobile performance. They talk about like not overfetching, basically stuff that you might care about for loading time, but it doesn't feel like it helps you develop your app any faster. And so a lot of times people have questions like, yeah, like maybe this will make my app load faster, but is it going to make my life way harder as a developer? So that's one of the things I'm on about these days to help try to correct. Just to start off, I guess a few questions. How many of you guys have heard about GraphQL before? Is that everyone? I guess you're here at a GraphQL presentation. Have you guys used it before? Have you tried building anything? Does anyone raise your hands if you tried it? Okay, great. So not too many people. So that's good because then a lot of this will be new stuff, which is always better. Cool. So let's start with a somewhat brief history of what web apps have looked like in the past. Something we spend a lot of time thinking about at Meteor and on the Apollo team. So, for a long time, web apps were all about sending HTML from a web server to a client. A lot of web apps are built that way today. But, with the rise of Angular and then React and then a lot of other tools, and especially because you can't even really do server-side rendering for mobile apps, if you're writing a native mobile app, people have had to think about ways to break out of this model. And so, people are often now sending a bundle of code to their client that includes some of their UI code and some logic, and transferring only the data from the server to the client after the initial load. There's some hybrid approaches as well. Those are good, but this has a lot of benefits. Like your app gets faster because you don't have to reload all the HTML every time. You don't have to reparse the JavaScript. Great things like that, but it's also not super easy. So, you might start out having multiple clients, which is great because it makes you feel really good about picking the data API approach because now you can use the same API for both clients, which is really cool. But then you might also want to have different microservices and different APIs on the backend. And if you have multiple clients, you have different APIs on the backend. You end up with a situation where they all need to communicate in various different ways. And some people will do this by calling the microservices directly from the different apps and clients. Another option that that people do is they have an API gateway, which is basically a single server in the middle or a service or a set of services that acts as, on the one hand, it's great because it organizes all of your APIs. On the other hand, it becomes somewhat of a bottleneck because now you can't really easily add a feature to one of these apps without adding it to the API gateway, or you have to go around it, which is also not ideal. And what happens is because this API gateway is just one thing, it also isn't really optimized for any of the clients that are talking to it. So you might have, I guess Facebook examples always come to mind because they kind of brought GraphQL to everyone. But if you're thinking about Facebook, like the newsfeed, that might be displayed in different ways in a native iOS app, in the web browser, on an Android app, on Facebook Lite, which is this client they have for people with like slow network connections, basically. And so in that situation, you don't want to have just one endpoint called newsfeed that just returns a giant blob of data because it might be way too much data for some clients, and for other clients, it might not be enough. They might have to do multiple round trips. And this is just recapping some of those problems, and specifically problems about who is supposed to even be developing this API layer, right? So it's already really hard to make it efficient, but it's also really hard to know who should be in charge of deciding what those endpoints look like, right? If your backend team is developing it, that means you have to go talk to somebody on a different team every time you need some new data. If your front end team is developing it, I am a front end developer myself, so I feel like it's okay for me to say it, but I've heard that sometimes front end developers aren't always writing the most secure API code. If you're trying to ship a front end feature out the door really quickly, the first thing on your mind is speed of development. And yeah, so basically, you know, you're stuck between a rock and a hard place here. And so that's kind of a big problem that GraphQL is trying to solve by being what we think is pretty much the best API gateway to connect all these different clients you have to all these different backend services you have. And this is basically a pattern we see at pretty much every organization we've talked to has one or more of these types of things. So can GraphQL be the best of both worlds, where you can have the front-end team have enough abilities to modify the data they're getting back from the API, and the backend team have enough ability to describe what the data is, but not have to go and change it very frequently and keep it secure and performant. So yeah, so for people who haven't worked with GraphQL before, go over a couple of introductions to what the benefits are and what it does for you. So the main concept in GraphQL is really that instead of sending a single request with a URL and like a set of parameters, you send a request with a GraphQL query, which is this string on the left. So you can see this is an example of a GraphQL query in a particular response you might get to that query. So how the server generates this response from that query on a technical level is up to the GraphQL implementation on the server. But from the client's perspective, you can see that it looks pretty much like the JSON result on the right, except with just the field names that you want, right? So, you know, you are trying to fetch a human from your API. It's kind of a funny name for a field now that you think about it. But you're trying to fetch a human, you know, with a certain ID. You only want their name and the height. You don't want, for example, their age, or you don't want their entire like employment history or whatever, which is something you might get back from a REST API. You actually don't really know what you're going to get back. Somebody might add more stuff later as well, making your app less performant without your involvement. So basically, in this case, it's cool because we can select the fields we want and not get any other fields. It's also really cool because any field can have arguments on it. So it means that pretty much any field can be a computed field that's computed by the server. So, you know, if you were going to have some logic on the client to convert various different units, you know, for example, you might want to get the height in meters or feet or something like that. You can put all that logic inside the server and not have it bloat the response of your API, right? In an API that doesn't have arguments on the fields, you might have to return two fields now, like height in meters and height in feet, and then you have like 100,000 fields, and it's really bad. So here you can make your API more powerful without making it slower, basically. And the other important thing here is that, wow, every time I click it skips a lot of slides. Okay. Yeah. So the other thing that's really important is not only can you select fields and pass arguments to them, you can actually, for some fields that are objects, you can traverse inside them, right? So essentially, you know, if we get this human, we want to get some of their friends, we can just query the friends field, and then inside there we get a whole other list of humans on which we can query the same fields that we could before. So basically, no matter how much data you want from your backend, you can get it with just one query, depending on how your server is designed. And the other thing that is not really mentioned on this slide here, but is really important, is that all of this is described on the server by a GraphQL schema. And a schema is a description of the types of fields and objects that are available in your API. So when you're writing this query, as we'll go over later, you can find out if it's valid or not by looking at that schema. And yeah, and one cool side note is because these queries are really powerful, you can use powerful clients to query them, which we'll also get into in a second. And then the last thing that's a critical part of any introduction to GraphQL is that it's not a library and it's not a specific technology. You guys might have heard of, I don't know, I guess Falcor is a good example. Has anybody heard of Falcor here? So basically, Falcor has some similar properties to GraphQL. It's also a API technology that lets you fetch specific fields, filter the fields you only need. But the thing about Falcor is it's a GitHub repository. It's a library that you download from npm and then use it to fetch data. GraphQL is very different from those because it's a specification. So you go to Facebook's website that lists the specification for GraphQL. It has a pretty detailed description of how GraphQL is supposed to work, and that's enabled people to implement client servers and various tools for all kinds of different languages and front-end technologies. Like pretty much if you can name it, it probably has some sort of GraphQL thing for it already. It's like such a spoiler. Yeah, so to summarize this part, basically, with REST, you have to always be thinking carefully about what needs you're going to have from your API, design it carefully to be performant in various situations depending on what data you need for different clients. And then you need to write special endpoints to serve those needs, and you need to constantly be talking between different parts of your technology to figure out what those need to be. With GraphQL, in this glorified thing, wow, I just want to click once. Yeah, you just ask for the data you need, and the server at runtime returns the only data you need without having to involve someone creating a new endpoint. And my favorite metaphor for this is, this looks kind of funny because obviously iPhones are way better than rotary dial phones. But I think it's actually a really apt metaphor because when you have a phone with buttons on it that can only make calls, the only thing you can do is what the original designer of the hardware wanted you to do with that device. But with GraphQL and with a touchscreen device, uh, the screen can change to show whatever controls you need at the time. So even though the calling functionality in these devices is roughly similar, you can make calls. The way you make the calls is incredibly more diverse on an iPhone. So totally reasonable metaphor. All right, so let's get into the main thing. So now that we've learned a little bit about what GraphQL is, we've heard about how it makes our API more performant, that it lets us communicate better with the backend team and not have to bother them about a bunch of requirements all the time. But how does that help you develop your UI faster, even after you have the GraphQL API? So the first thing that everyone uh, gets really excited about is if you guys haven't used GraphQL yet, if you have, you definitely know what this tool is. If you haven't, you might not. But this tool is called Graphical. So they took GraphQL and they put an I in the name over here, which is pretty clever, I think. But basically, what it is it's a web interface that lets you write GraphQL queries really in a really nice way. So, like I said before, every GraphQL server, it's part of the specification that it has to come with a schema. So, in REST APIs or in some other API technologies, you first implement the API, and then you write the schema for it later, or the other way around. But it's possible they're going to get out of sync or out of date. In GraphQL, those two things are things you define at the same time. So every GraphQL server is both guaranteed to have a schema, and it's guaranteed to be correct because that's something that the server uses while it's executing that query. One moment. So yeah, so since there's a schema, you can build a tool like this. So this is one of the tools that Facebook essentially launched alongside GraphQL that they use internally heavily. And it lets you explore your API just by typing. So the same way that, back when you had, I like Java, actually, I'm sorry. But back when you had languages like Java that were strongly typed and you could have Java doc and stuff like that, you could just hit dot in your editor and it would tell you like all the stuff you can do with this object. And with APIs, you often don't have that functionality with, JavaScript without typing. You don't have that functionality. But now with GraphQL, you get that same thing back for your API. So instead of having to go and read some documentation, you can just open an editor, start typing stuff, and kind of just guess how to get the data that you want. You can actually try this out yourself because GitHub has a public GraphQL API now, which is kind of in beta. But if you basically Google GitHub GraphQL API, you can sign into your GitHub account and then get this interface to your GitHub data, for example. So you can do that if you want to check it out. So yeah, so this is already really awesome, and this is one of the things that they launched with. But what other kinds of tools can you build once you have a schema and you have a really fancy query language? Oh, there it goes. Perfect. Did I skip any slides? No. Okay, great. So the next thing you can do quite easily now that you have a schema and you have these queries is you can validate queries that are already inside your code. So, you've gone to graphical, you've written this query, gave you all this nice auto completion, and now you paste it into your code. And in your code, it's often represented as a string. And the first response people have to strings in their code is, I don't want magic strings in my code, right? They could have the wrong syntax, they could be wrong, they could go out of date, whatever. But the best part about GraphQL queries, because they're specified, they're not magic strings. Um, in fact, there are plenty of tools. This is the first one we're going to talk about that can look inside your code, find the GraphQL queries in that code, and then inspect them as you would code. So, for example, if you get this ESLint plugin that we wrote a while back, you can run it on your code and find all kinds of problems with your API. So, for example, if you're changing your GraphQL schema over time, you can identify deprecated fields that you're not supposed to be using anymore, or fields that you made a typo in accidentally. Um, all kinds of stuff like that. And it's great because you don't have to do anything special or write your queries in a special way. You can just run it against any JavaScript code that's using GraphQL and it'll work. And the super powered version of this is this great IntelliJ plugin. So I don't know if people use IntelliJ or WebStorm, but one of the things you can get now is a plugin that will enable you to, there's a video, enable you to actually get that same auto completion and validation and stuff right as you're typing your code. So you don't actually have to even go to Graphical to do anything. You can just be in your IDE, start typing GraphQL stuff, and it will autocomplete for you. So here it's demonstrating how you can put in a path to your schema file that you can get from your server. And then when you're editing your queries, it will notify you about problems. So this is just the start of these kinds of services. People at Facebook are really interested in creating generic language services, so you can plug it into any editor IDE you're using, whether that's like Vim or Atom or something else. And we're really excited to collaborate with them. One of the things I'll show you later is some stuff like this they're working on for Xcode for iOS development. Yeah, so okay, so that's pretty cool because it gives us auto-completion in our editor, but one thing it's not going to do is validate our actual code. So once you've typed this GraphQL query and you fetch some data, you're probably going to use that data somewhere. You might use it in your UI components, you might use it in some client-side logic, and you still might run into a problem where you forgot to fetch a field that you needed, or you fetched too many fields, or maybe it's the wrong type. And so for that, the solution is code generation. So Facebook heavily uses code generation internally to load GraphQL data into their Android and iOS apps. And that's now something you can do with open source tools. So the most mature set of tools that we have are for Swift. So for iOS development, you can generate types. We also have TypeScript and Flow for people who are building their apps with React, as I've heard you guys are, and also for Java. So you can see here that given a GraphQL query, you can convert that into a set of TypeScript interfaces, for example, that you'll be able to import and for example, set the prop of your React component to be the shape of this query, and then when you use that data in your render function, you can know if you forgot to fetch a field that you actually need to display. And one interesting thing to note here is that if you take a GraphQL schema, which is basically a list of types of objects in your backend, the intuitive thing to do might be to generate a set of TypeScript definitions that represent those objects. But the more I guess modern is the word. I don't know if that's even a word for GraphQL because it's all modern. But the current generation approach for generating typings for GraphQL is to generate separate typings for every query. Because let's say we have this human type in our backend that has friends and it has a name and it has an age and whatever. If we typed a query that doesn't fetch their age, and then we try to use their age in our UI, and we generated types based on the complete available set of fields, then we wouldn't get an error. But because we generated it based on the exact query that we typed into our code, we'll know exactly what data we did fetch and what we didn't fetch. So basically, you can see how not only does having the schema make it much easier to write the queries, having the queries being written in a language that is well specified and parsable by machines, and you can associate with that schema, lets you write all kinds of tools that make your life even easier. So this is the tool I was talking about, which is the Xcode integration for GraphQL that we have for iOS. So basically, you can see on the right here, you can type a query in a .graphql file. So that's the file extension that we've been using, and I think other people are using for GraphQL queries. So you might be working on a particular UI component in your Swift app, and associated with that have a set of maybe GraphQL queries, GraphQL fragments. Fragments are basically a way to reuse sets of fields in different queries. So for if you have a UI component that uses, is trying to display a post, so it has a title, votes, and author. Wherever you use that UI component, you might want to be also using the fragment for that component. And basically then what you can do, I guess I can't really point for remote people, but this component has some functions that take as an argument this post details type that we have a fragment for. And so what that means is if we put that post details fragment in our query, and then we take that data from the query and we pass it into our UI. I don't know what people call UI components in iOS, but well, I'm going to call it component. And you pass that into your component, it's going to validate, even though the data is being fetched somewhere outside of it, this static typing will validate for you that the thing that fetched the data for you got you the right thing. And so yeah, so you get all kinds of rebuilds and stuff. I guess if you guys are going to be using React Native, it's not as relevant, but I guess you'll get a similar thing with TypeScript or Flow, for example. Yeah, and there's a lot of other benefits to using static queries. So again, basically targeting the idea that GraphQL queries are magic strings, people sometimes have the intuition that they should instead use a language-specific query builder, right? So you fire up your GraphQL query class, and then you say, add this field, add that field, add this fragment, which is something we've seen before. And while that might make it feel a little bit more familiar at first for people who are familiar with that programming language, I think it does rob you of being able to take advantage of really standard GraphQL tools like this. So you would have to re-implement those tools again for every different query builder or programming language you're using. So I think it's really the duality of the GraphQL schema and the query language itself that enables stuff to exist. Oh, and one other cool thing with the queries is one of the tools we're working on right now that we're going to publish a blog post about next week is a tool to do persisted queries. And so persisting queries means, like in this diagram, you can look at all of your UI code, run some code to identify where the GraphQL queries are, like we did with the linter plugin, pull all those queries out into a separate file, and then save that to your database. Because another big question people have about GraphQL is security. They say, well, if the client has all this power to request all these different fields, how do I know that somebody's not going to come along and like scrape my entire backend with one query? Or even just do a query that will take too long to execute, like, and be inefficient. So the easiest way to solve that is to simply not let people run any queries that you haven't pre-specified for them. So we're gonna release a really easy tool that lets you run a single command on your code, save all those queries to the database, and then make sure that when a query comes in, it's one of the ones that you wrote in your code and not some attacker wrote for you. And that lets you more easily test all the queries, make sure that you have a list of all the ones you're expecting, and make sure they're fast and correct. All right, so we've been talking about developer time tools. I want to get a little bit into runtime stuff. So what can you do if you have fancy GraphQL clients? I could give an entire talk about this stuff because what I've been doing for about 9 months is developing a GraphQL client called Apollo client, which you guys, well, at least you used. I like it a lot. But we'll talk about some specific things here. So yeah, so the first thing is, what even is a GraphQL client at all? And the secret is you don't really need a GraphQL client. You don't have to use the library I wrote or anyone else wrote to query your GraphQL server at all. I think this is like actually a pretty common misconception because when you look at the queries, they look kind of fancy. It looks like you need some sort of compiler or something like that, but you really don't. All you need to do is take your GraphQL query string, put it into an XHR or a fetch call or anything that you use to make HTTP requests, send a post request, and you'll get the result back that the server generated for you. So that's enough to build your UI on top of GraphQL already. It's going to be simple. It's going to be predictable. However, what's going to happen is you'll end up with a lot of different UI components that are doing GraphQL queries in different places. And those queries might be overlapping and fetching the same data. And you won't have a super easy way to identify when that's happening. So you might fetch some data in one place and a different place, and they might be displaying different content because they fetched at a different time, but even though it's the same thing. So it might get confusing. Basically, you're not going to get something like UI consistency out of the box. So that's one good reason to use a caching client, which is a client that does GraphQL queries for you and then saves all of those results in some kind of client-side cache. So that makes it much easier to update the UI after you've done a modification to your server data. You can just update the cache on the client to re-render all your components. It lets you manage all your data in one place rather than having some requests all in different places. Just like with Redux, if you guys have used that before, you can look in one place and see all the data you have access to. And one thing we're going to get to in a second is that you can have access to great developer tools that take advantage of these fancy clients to show you what's going on in your app. Yeah, and one other benefit is even though it takes a little bit of effort to set up the client in the first place, once you do that, it's very easy to use it in your UI. So this is, I'll be the first to say this is a quite simple example, but if you have your GraphQL server set up. All you have to do to attach some GraphQL data to a React component is called this GraphQL higher order component. And then this post list component down here will get all the data you want. So it's pretty easy, at least to start with. So yeah, so the thing I'm really pumped about is also a thing that we launched very recently as part of kind of a company hack week, but it's a thing that our team has wanted for a long time while we were building our product, which is built entirely with GraphQL and Apollo and all these tools, is something that will help you, much like the Redux Dev tools. Have you guys used the Redux Dev tools? Someone raise your hand if you have. Okay, actually, not that many people, but those people were nodding. So basically, the idea of these dev tools is, now you have this complicated piece of machinery in your app, which is a GraphQL client, which is doing queries for you. It's storing data somewhere on the client. Depending on whether or not you have that data already, it may or may not fetch it again from the server. So we found it really convenient to have a tool that helps you understand all that stuff. And so we built a Chrome extension that lets you actually look inside Apollo and see exactly what it's done and what it's doing. So for example, this view shows you the set of objects that it's fetched and that were cached. So this list down the left side is all of the objects. So this is a screenshot from Optics. So for example, you have some services objects and some subscriptions objects, just like businessy stuff, I guess. And so you can inspect, what's going on in your app, even though you didn't write the code yourself, you can see what's going on. Some other features this has are, like I said before, you can attach GraphQL queries to your UI components. So this gives you the list of all the queries, what components they're attached to. And then the last thing it gives you is that super cool graphical query editor. You can get it right in your browser now. So all you have to do is load up the app that you wrote with Apollo and React or whatever, and then you open the dev tools and you can start both typing queries and running them against your server, whether it's in development or production. And another thing that's really cool you can do is you can pull out the queries from your components and start editing those. So you can go to that view I showed you before, click on a button and think, well, what would happen if I fetch an extra field here? And you can do that right away from your browser. So yeah, so if there's one theme here, it's that we spend like 98% of our time thinking about the developer experience and the tools that you get when you're using GraphQL, because when we started looking at it back in November, that was the part that we felt was really missing, but had huge potential. Right? When we saw GraphQL with all this information available about the queries and the API, we were like, yeah, but people are still just writing like strings in their code. And so that's why the most important thing to us was to build out all this stuff. And now we get to real-time updates, which I've heard are like a pretty hot topic around here. So GraphQL has pretty much, in today's version, has about two things you can do with it. One is a query, which lets you fetch data. The other one is a mutation, which lets you update data. So, in a REST API, there'd be like a GET request or a POST request. But from various talks given by Facebook about what they're doing internally and some experiments in the community, a third thing is approaching, which is called a subscription. So in addition to querying data and modifying data, there's now this extra feature of essentially a pub sub system. So this is a diagram from a talk at React Europe, I think from this year. And basically here, I guess there's a lot of arrows, but the main point here is GraphQL subscriptions are a concept that lets you push updates to the client in response to a server-side pub sub event. So for example, Facebook's example is always like somebody liked a post and you want to show people in real time on their page that that post was liked. So they already internally have some sort of pub sub system, which is sending around these messages when certain things are liked or updated. And so they hook into that and basically automatically run a GraphQL query for you and push that result to the client. So there's a few questions here that you can get into. One good question is, why would you even use GraphQL for this? Which is really a valid question. And I think there's a really good reason, which is you don't have to do multiple round trips, the same way that you wouldn't have to do with a, compared to a REST API, you have to do fewer round trips, and the same with subscriptions. So in a different system, you might, for example, get a notification on the client and then think, well, I got a notification that there was a new like. Well, what do I need to refetch in response to that? And then you would end up doing an extra round trip to fetch that data from the server. Okay, then you might think ahead and think, okay, well, I know every time somebody likes a post, I'm going to want to display the new number of likes that post has. Um, well, and then you just put that number of likes into the message that you send to the client. Well, now you're in the same land that you were with the API before. You now have this message, which is hard coded into your server. And depending on what client is using that, it may or may not need to fetch a lot of additional data. So that's the reason that you want GraphQL for your pub subsystem as well, which is when you receive this event, you can tell it ahead of time, also send me all this additional stuff about this event that happened. So that's basically the third concept we're working on, called GraphQL subscriptions. So we've been trying to get this technology to production in the community. So it's something that Facebook has been using for at least a year, if not more, giving a lot of talks about it, but I think they haven't had time to really solidify it and make it something that is like an official GraphQL thing. So we're trying to take on that responsibility. So we've been working with a lot of people in the community, in the GraphQL community, and also people at production apps to get GraphQL subscriptions working. And we're also currently working on getting those into our own production apps as well. So for example, this is a diagram from a proposal or a blog post that we published recently that laid out how GraphQL subscriptions might work in JavaScript. So you use the regular JavaScript GraphQL execution engine. You use your GraphQL clients, but in between, there are some components that define a transport and some that define when these subscriptions are supposed to rerun. And it's been really great because people in the community have picked this up and started experimenting with it and doing some really great stuff. So, for example, somebody in the community implemented a Redis plugin that lets you, in development, for example, you can just send in-memory messages to update your subscriptions, but in production, you can use Redis specifically for this package to publish those across the network. So, you might do a mutation that might send a message to Redis, update a subscription, and some other client gets notified of your update. But we're also seeing people implement plugins for various other messaging services. So, some examples are RabbitMQ, MQTT, maybe something that even uses database triggers to update those subscriptions. So there's a ton of things you can do once you have the basic abstractions. So yeah, like I said, this is something that one of our main goals right now is to make this something in the GraphQL specification so that it's clear when you do a subscription against the server what exactly is supposed to happen, because there's been a lot of articles written about it and a lot of reports from what people are doing in production, but nobody has yet taken the time to write all of that stuff down in a concrete description. All right, so I think one of the last things is, so we talked a lot about what you're doing when you're developing your application and what kinds of tools you can have to both write your queries, inspect them after the fact, all that kinds of stuff. So can GraphQL help us in production? Other than our application performance, which we already know about, we can send less data. Can it give us more insight into what our API is doing? So I think it can. That's why I put the slide up here. Um, Great. So let's think about some things we might want to know when we're sending a GraphQL query. So let's say we're a backend developer. So what we've implemented when I say backend developer, I mean GraphQL API developer, somebody who's developing the API gateway, for example. What might they want to know about their API? So one thing they might want to know is how it's used. In a REST API, probably the way you would find that out is you would record which endpoints are being called. Probably the URLs, maybe the parameters, depending on your security requirements, etc. Unfortunately, for GraphQL, that doesn't work anymore because there's only one URL you're now calling, and there's a large multitude of queries you might be doing. So one question you might ask is, I defined all these types in my schema, and I defined all these fields on those types. How are those fields actually getting used? So, maybe it's really expensive to compute the friends for a human, but then you can look and see that not many people are using that. But if you have a field that is both commonly used and expensive to compute, that's something you might want to take a look at as a backend developer. From the front end point of view, you might want to get even a little bit more autonomy. So you already have the ability to write queries to fetch all the different kinds of data that you need. But one problem is, you get one result back. So, let's say you did your GraphQL query to get all the data you wanted. It took like 400 milliseconds to execute. And you're like, well, that's not ideal. So I want it to take 100 or 200. And depending on what kinds of tools you might or might not have and what people have access to those tools, it might be pretty hard to identify whether it's a particular database call or if it's a particular field. But with GraphQL, because your query is composed of individual fields, which are all part of the public API, you can give people a report of which fields are expensive without necessarily needing to tell them like what backend they came from or what logic was used to execute it. So as a developer, it would be really useful to be able to type a query and then know that if you remove this one field, it would execute twice as quickly, because then you could send that as a second query after the fact. So that's also really cool. Well, thankfully, we have a product that does exactly that thing. So yeah, the first production tool we were working on for GraphQL is called Apollo Optics. And what that does is it shows you more or less the two things I talked about before. So it helps both front-end developers and back-end developers understand how their API, is this video gonna loop or what? Maybe not. This is like not the nicest part of the video. Well, so the, at the top here, there's a histogram. Oh, okay, I guess this is a longer video than I expected. But yeah, so for example, this part of the view is something that gives you the statistics I was talking about before of which fields are being accessed on which types. So as a backend developer, you might look at this to see what kind of impact there is. You can click on any of these and actually go to, oh, this is the next slide. Still having trouble with the slide. So yeah, as a developer, you can click on any of these fields that are all linked and see what queries are getting used in. So you can go find out which query is querying this field in your API. You can use that to track down either the UI component that is requesting that, or the UI developer that wrote that query, to find out how important it is to them. So maybe they can remove it, maybe it needs to be made faster. Going back to the other thing, you can see there's a histogram. So this is a particular view for a specific query, right? So, I can open up the app in a second and show a little bit of more of a demo, but you can see basically all the GraphQL specific information you might want that turns this GraphQL black box into something you can actually inspect. And so one last thing I want to talk about is something that we've been kind of cooking up is essentially a new workflow for development, for all programming. No, yeah. So it's basically, you guys might have heard of component first development. So the idea that you can develop uh, the UI of your application by looking at individual UI components, developing those separately, and then putting them together into a finished whole. You later might want to build a library of all those components so that the next product you build, you can just put them together like Legos and have a finished UI. That's been working really well for us. So we're thinking, could you apply similar concepts to your API? And the problem is, before, your API was not very modular, right? Depending on the components that are on the screen, you might need dramatically different kinds of data. But one thing we've noticed is that GraphQL enables a similar approach to component first design, but for your API. So this is going to be a good one. How many of you have had to draw a diagram like this in the past? Come on, raise your hands. Okay, there we go. So I remember, I think primarily drawing these in various software engineering classes, where this is always the first step to developing any project is putting together one of these diagrams with foreign keys and fields. And I think that was actually really cool because, I think somebody said, I should find out who said this, probably some famous person, that like, if you show me your schema, I can guess what your app is doing, right? If you look at the types and the fields, you can pretty much understand, this is going to be something that involves contacts, like pretty easy. You don't even need to see the UI to know what it's going to do. The problem is that in today's world, you don't have one database with a single schema. You might have a lot of different kinds of databases because they have different characteristics. You might have some APIs. So it's not going to work anymore to draw a diagram like this for your entire SQL database and be done with it. But thankfully, like I said before, GraphQL comes with a schema. So not only does GraphQL have a concept of a schema, it literally has a physical schema language. So you can write a text file that will define what kinds of types and fields you have in your GraphQL API, and you can use that for all kinds of useful things. So for example, here you might be defining a type in your schema that represents a comment on some kind of post. It references other types. For example, the posted by field references a different type called user. Some of these are built-in types like int and string. But the most important thing about this is, in the same way that that SQL schema represents the contract between the database or the database admin and the person running the queries, this might represent the contract between your API and your user interface, which is, in today's world, I think, a lot more useful, or useful to a wider variety of people. And the even best part about this is there are now tools that let you use this schema language in various ways. So for example, to mock your data. And so what does that let you do? Well, it lets you do exactly what we did when we developed Apollo Optics, which is the product that I showed a little bit, and I can show you guys it in action. Is we built the whole thing in parallel. So first, a bunch of people, not too many people, some people, sat in a room and looked at a file like that or some representation of it, and thought, okay, we're gonna build the UI. Somebody else's, like the other people in the room, are gonna build the API, and you can agree what kinds of fields you might want in there, right? There's a couple of tensions there, like backend developers probably always want fewer fields because it's less stuff to maintain. Front developers will probably always want more fields because it's less stuff for them to maintain. But either way, you can agree on that stuff ahead of time, to a certain extent. Then, because you have this super specified contract between your API and your UI, you can mock out all that data with like zero effort. You can literally, there's a library where, now I wish I put the code snippet here, where you take the schema file, you put it in, and you get an API that you can run queries against that will give you the right shape of data every time. And the backend developer can look at this schema and build something that pretty much looks like that. So it might not always be 100% correct, but at the end, you can glue them together. You can use all these schema validation, query validation tools to find 100% of the edge cases in your code that might not match anymore, because you can validate with complete certainty that the queries in the client and the schema on the back end will work together. And then you can launch your app. So we launched this app much faster than expected because of the ability to do this. So you might think of it, yeah, like a similar to component design where you can have people working independently and then bring their work together at the end. So in conclusion, we heard about a lot of different stuff, but mostly it's about how there's a shared language you can use with GraphQL, one to describe your schema, one to describe your queries, and both the backend and the front end developers can use that shared language to talk about data provided and data requirements. You can use these languages and specifications to build a whole wealth of tools, and this is just what people have come up with in about a year and a half, or maybe 2 years at this point since GraphQL is released. So you can imagine way more stuff like this and way more futuristic tools. You can get insights in production into the performance of your API from like many different directions, and people who are developing the API can really understand exactly how it's being used. So I think GraphQL is going to be a pretty transformative technology, and already is for people in not only how efficient your app can be, but also how fun and fast and safe it is to develop. And that's the talk. Thank you.
Questions?
Yeah, we have 10, 15 minutes for questions. So
Awesome.
Yeah, please ask me stuff.
So it seems like a pretty obvious choice when you have JavaScript clients that you care about latency and performance. What about when you've got something where like gRPC is an option and you have to kind of balance the performance between the two? Do you know is there any obvious breakpoints where one makes more sense over the other one, or is there any plans to leverage some of the performance benefits of gRPC with GraphQL?
Which performance benefits specifically?
Just like the encapsulation and being able to define the schema and being able to it looks like the response comes back as like JSON, right? Which is plain text. It could be.
Yeah. So there are two dimensions to this question. The first is Pierre is itching to answer some stuff, but you can go after me. Yeah. So the first part is what I read from your question is parsing JSON, for example, can be inefficient, right? You don't necessarily always want your mobile app, for example, to be parsing giant JSON blobs on the fly. So the answer to that part is there's nothing that says you have to send GraphQL responses with JSON. That's by far the most common way people use it in the community, but that's not even the way the Facebook Android team uses it. They use something, I forgot which specific thing it is, but they use like a binary transport basically, and then what they do is they compile their GraphQL queries into functions that decode that binary transport directly, right? They ensure that all the fields are sent in the same order that they appear in the query, and then that lets you build a really efficient parser that just uses like memory offsets instead of actually parsing the string. So that's one angle. Unfortunately, those tools are not yet available in the community. So Facebook's mobile stuff is like highly optimized for their specific use case. So it's going to be up to probably other people to bring those tools there. So we are working on also code generation tools for Android, and so maybe that's one of the things that they're going to do. The second part, which maybe is not as relevant to your question, is if you're already using gRPC for your backend services, how might that work with GraphQL? Um, and so basically, yeah, GraphQL could act as an API gateway on top of any number of gRPC services. So when you call those fields in your API, that field with an argument might just pass that argument along to some gRPC service in the backend, and that's actually uh, definitely a really common way people use it today. But yeah, but having more efficient transports between the client and the server, which is where GraphQL is really the most optimized from a developer experience point of view, is like definitely a priority depending on how much data you're sending, how many queries you're doing. Pierre, do you have anything else?
Yes, so GraphQL is actually transport and format agnostic, as you mentioned. So you can absolutely use GraphQL over gRPC. Use something like message pack for the response formats. So the only requirement is that you can serialize, numbers and strings and objects, etc. And performance-wise, the overhead of using a GraphQL execution engine is really, really low, right? So the introspection query in GraphQL, which returns for an empty schema hundreds and hundreds of objects, takes around 50 microseconds on the JVM. So there is an overhead, but it's very likely you can pretty much ignore it. It does allocate a lot, but everything is going to be short-lived, right?
Yeah, and that's definitely one of the biggest benefits of using something like this persistent query approach, right? If you write your UI in a way that all the queries can be easily extracted in a static way, then that gives you way more performance options than if you're accepting completely dynamic queries.
Well, and to add to that, in the case of optics backend, we don't use pre-computed queries, but we cache the parsing and validation, and so that shows it's a few hundreds of microseconds as well.
Cool. Any other questions, or maybe from remote people even? Yeah, I can certainly. The somewhat question was, can I talk about server-side rendering? One thing I think I can also do, if there aren't too many questions, is just show. Well, this is optics here. So live demo is never a good idea. But yeah, this is a particularly interesting query from one of our other apps called Galaxy, which is a hosting service. So this is a particular query which does a lot of parallel accesses. So all of these bars that you're seeing here, you can click and see the query. So this is the GraphQL query, which is fetching the list of apps that a particular user has in their account in our hosting platform. And that fetches the apps, the number of apps, a bunch of different related stuff for each application that they're looking at. And then, so basically the idea here is that you can look at this trace, which is going to tell you for the fields that take up a significant amount of time, like, you know, I guess this person only has like one app for that particular query. But yeah, but you can look at, various queries that take different amounts of time and see how much time they take. And along with other metrics like, on average, which fields are accessed both for that query and also all queries in aggregate. So that's that thing. In terms of server-side rendering, so I promised that it would be really easy. So I'm just going to show you the docs. So this is our website for Apollo client, the GraphQL client that we maintain. So one of the things you can see on this website is code snippets for various platforms of how to use it. So here we have, for example, a snippet for React Native. So you define a React Native component here, you put a query on it. This one down here has a video, so that's pretty cool, I guess. But anyway, what about server-side rendering? So down here in our docs, we've got a bunch of recipes we say that are like various integrations and things you can do. So for server-side rendering is really great because the only thing you have to do is pretty much. I think I even missed the code that does it. Oh, rendering code C below, right? Yeah, yeah. So this is the code you need to do server-side rendering. So you get your app, which is a React component, and you call this function called get data from tree. And what that does is it has essentially a custom React renderer, which will basically render your entire component tree, but instead of printing HTML, what it's doing is it's figuring out what queries you're asking for and then fetching them and then traversing further down the tree. So even if you have multiple queries that are depending on each other, This will get all of those requirements. It will fetch all the data, and then what it does is it puts them into the client-side cache that I was talking about before. So it attaches it to this instance here. Yeah, there we go. And so what that means is you can now do two things. One is you can call render to string, which will generate your actual HTML. And the second thing you can do is call get initial state on that client object. So not only can you server-side render your app, you can also get the initial state so that when your app boots up on the client, it already has all that data pre-populated. And for a developer-defined interval, for example, 100 milliseconds after your app starts up, you can have it avoid sending any queries to the server intentionally. So you can say any query that is run during this page's startup, I expect to already have run on the server during server-side rendering, so don't run that. And so your page becomes fully interactive, doesn't do any additional requests, and everything is like properly booted up. What was I going to say? Yeah, I think the thing that's really cool about this approach is we've seen some other server-side rendering approaches for clients like this that require you to move all of your data fetching into the router configuration. And so that was one of our biggest goals, was to not make people do that, because when you have to do all of your data loading in the router, that's when you, from our perspective, lose a lot of the benefits of doing component-based development in the first place. Because now instead of thinking about components, you're thinking about routes, and that makes me think of like HTML apps from a long time ago. That's a personal opinion, I guess. But yeah, the really cool thing here is, yeah, we basically we wrote our example app. We wrote the server-side rendering feature. We typed in the code, and then it worked from the first go. There was nothing we had to change about the actual code. Yeah, there's like a couple of additional features that we got from production users that were using this, like the ability to skip certain queries while you're doing server-side rendering, the ability to do all that stuff in one go. So there's this render to string with data thing. So yeah, so I would say it's pretty sweet as far as server-side rendering features go. And yeah, there's a bunch of other things that I didn't mention because, like I said, I could give a whole talk about just different features that Apollo Client has. And the coolest thing about it is that they're all informed by what people in the community ask for. So there's a certain set of features that we're using in optics, and then there's another set of features contributed by various people or asked for by various people. Like I think we're pushing 150 or 200 contributors now across various Apollo stuff. So that's been the best part for me, is making something that people can really call their own, because not all projects are like that. So yeah. Does anybody have any other questions or thoughts? Cool.